It's 2023 and AI is already at the point where it not only affects but also improves our daily lives. If you think it's just about ChatGPT or Bert, well, that's just not the case. It is everywhere, from personalized Spotify picks to money lines, recommended products on Amazon, what factors determine house price, and the next ad you're going to see on your social media feed. But what drives AI? Algorithms and machine learning models. So today, we will be looking at the top 15 AI and machine learning algorithms that are at the backbone of this revolution. Number 1. Neural networks. The first type of algorithm that we'll be discussing today is neural networks. This algorithm mimics the workings of a human brain. A typical neural network consists of interconnected nodes or neurons organized in layers to process and analyze data. These networks are used to solve complex problems such as image recognition, predictive modeling, and natural language processing. Chatbots like ChatGPT and Bert have neural networks rolling in the background. The basic operation of an artificial neuron involves receiving information from a previous neuron, processing it, and passing it to the next neuron. This process is similar to how impulses are received and transmitted in biological neurons. Neural networks learn from labeled or unlabeled data and continuously improve by adjusting the weights of the connections between neurons. They have been applied in various fields, including medical diagnosis, targeted marketing, handwriting recognition, speech-to-text transcription, and facial recognition. Number 2. Linear regression. With neural networks out of the way, let us now talk about linear regression. Linear regression is not any revolutionary brand new idea. In fact, it was first found some baffling 200 years ago. However, linear regression, which assesses correlations between independent and dependent variables, can be quite useful when developing a self-learning algorithm. The linear equation y equals ax plus b is used to carry this out. For instance, if you offer a machine learning algorithm two independent variables like age and wealth, the system can estimate whether or not the user is likely to buy the product. The world of computer scientists and ML engineers attribute this algorithm to be the best machine learning method ever created. Number 3. Logistic regression. The next member of today's list is logistic regression. This is basically a statistical method used to analyze and model the relationship between a binary dependent variable and one or more independent variables. It works wonders when we want to calculate the probability of an event. Say we want to predict whether a customer will buy a product or not based on their age, gender, income, and other factors. We have the data and we call upon the logistic regression function for help. The model uses a function known as a sigmoid function to map the input values to a probability between 0 and 1. The output of the logistic function is then used to classify the input into one of two categories. This model is actually trained on the labeled dataset, where the dependent variable is binary and the independent variables can be continuous or categorical. Number 4. Decision trees. Moving forward, we have the decision trees. It is a supervised machine learning algorithm, meaning it's trained on labeled or verified data. Used for both classification and regression tasks, it is a tree-like structure where each internal node represents a feature or attribute. Each branch corresponds to a decision rule, and each leaf node represents the final decision or prediction. Decision trees follow a set of if-else conditions to visualize the data and classify it according to the conditions. For example, a decision tree can be used to predict whether a person is likely to buy a new car based on their demographic and behavior data. The decision tree would have nodes representing different attributes such as age, income, and previous car purchase history. Based on these attributes, the tree would make decisions and ultimately lead to a meaningful prediction. Number 5. Random forests. Random forests are actually pretty much the same thing as decision trees. A decision tree is a single tree-like structure that recursively splits data based on the most informative features. However, it is prone to overfitting and may not generalize well. On the other hand, a random forest is an ensemble method that builds multiple decision trees on random subsets of data and combines their predictions, reducing overfitting and improving accuracy. You see, when there are a lot of trees, they make up a forest. That is the analogy at play here. Random forests also introduce randomness in feature selection and aggregation. reducing variance and improving generalization. Number 6. Gradient boosting machines. Next up, we have gradient boosting machines. Basically, boosting is a technique that is used to convert weaker learning algorithms into more powerful ones. This algorithm is the main resource when the task is to analyze loads of data at extreme precision. The AdaBoost algorithm, a type of gradient boosting, initiates the proceedings by assigning an equal weight to each observation and building up a decision tree. After the first tree is evaluated, the algorithm increases the importance for the observations that were difficult to classify and decreases the weights for the easily organized observations. This process is repeated for a specified number of times, resulting in a tree of well-classified data. Recently, researchers over at the Center for Applied Research and Remote Sensing in Vietnam used these machines to classify world land cover, a map that represents spatial information on different types of Earth's topography. Number 7. Support vector machines. Support vector machines is another supervised machine learning algorithm used for classification and regression tasks. It works by finding the best possible line or decision boundary that separates data points of different classes. Suppose you have a data set with red rectangles and blue ellipses, and you need to classify them into two classes. The SVM algorithm finds the points closest to the line from both classes, called support vectors, and computes the distance between the line and the support vectors. It then outputs the decision boundary that best separates the classes. Anything falling on one side of the decision boundary is classified as one class, and anything on the other side is classified as the other class. Number 8. K-means clustering. The algorithm aims to group similar data points together and discover underlying patterns without referring to known or labeled outcomes. It works by iteratively assigning data points to the nearest cluster based on the mean value of the cluster, and then recalculating the mean to optimize the positions of the cluster's centroids. To understand, consider a dataset containing dimensions of different flowers. K-means clustering will group flowers in a dataset based on features like petal length and width. The algorithm iteratively assigns flowers to the nearest cluster and recalculates other clusters until the point of stabilization, effectively grouping similar flowers together. This algorithm can help in programmatically distinguishing different variations of animals and plant species. Number 9. Principal component analysis. To understand principal component analysis, imagine a dataset with hundreds of values such as height, weight, age, income, education level, and many more. The dataset is quite extensive. This is where principal component analysis comes to help. It helps in reducing the dimensionality of this dataset by finding a new set of variables that retains most of the original information. It does this by identifying the directions in which the data varies the most. In very basic terms, it will find the most important features that actually impact the outcomes while disregarding the many irrelevant ones. Number 10. Naive Bayes. Naive Bayes is a probabilistic algorithm that calculates the probability of different classes based on the presence of certain features, making it a valuable tool for machine learning applications. To understand this algorithm, consider a dataset that describes weather conditions for playing golf. The features include outlook, temperature, humidity, and windy, and the class variable is play golf. Naive Bayes assumes that each feature makes an independent and equal contribution to the outcome, even though this assumption is not generally correct in real-world situations. But still, these independent assumptions often work pretty well to give an idea about the conditions in play. Number 11. KNearest Neighbors. KNearest Neighbors comes in at number 11. KNN algorithms stand out from the rest of the algorithms because of its wide usage spectrum. It finds the most usage in anomaly detection and image processing. The algorithm works by first storing all the available data, which means that it is computationally expensive. When a new data is given to the algorithm as an input, the algorithm compares the new data with the existing data, checks for anomalies and similarities, and then classifies it into the relevant category. Number 12. Reinforcement learning. Reinforcement learning is a trial and error based machine learning algorithm where an agent interacts with an environment, receiving rewards or penalties for its actions. RL includes algorithms like Q-learning, policy gradient, and actor-critic methods, each estimating cumulative rewards differently. In a practical example, a robot navigating a maze aims to reach a goal. The robot learns the optimal policy by receiving feedback in the form of rewards or penalties based on its actions, gradually improving its decisions through trial and error to increase the probability of reaching the goal. This algorithm is great for teaching robots how to play video games. Number 13. Auto-encoders. We are down to the final 3 algorithms for the day, and now we will be discussing auto-encoders. Auto-encoders consist of an encoder and a decoder with a bottleneck layer in between. The encoder compresses the input data into a lower dimensional representation, and the decoder reconstructs the original input from this representation. Auto-encoders can be used for tasks such as data denoising, dimensionality reduction, and anomaly detection. We can use an auto-encoder to compress images of handwritten digits into a lower dimensional latent representation and then reconstruct the original image from this representation. Number 14. Bert. Bert, or bidirectional encoder representations from transformers, is a leading natural language processing model introduced by Google researchers in 2018. It operates as a pre-trained deep learning model utilizing a transformer architecture to comprehend word context in a sentence, generating high-quality text representations. Bert aims to enhance computers' understanding of ambiguous language and text by considering surrounding text for context. Bert is used heavily to understand people's Google searches. Number 15. SelfReward Evaluation Algorithm. Now is the time for the final algorithm for the day, which is basically an extension of reward-based reinforcement learning. The algorithm boasts the prowess to function independently of task-specific prompts or predefined reward templates, making it simple to incorporate human feedback to fine-tune awards and better match them with developers' aims. This improved training efficiency by quickly evaluating the quality of large batches of prospective reward candidates. NVIDIA came up with this algorithm, and it is actually being considered as the world's first AGI because it handles rewarding systems way better than humans. Subscribe to AI Symbiosis for more knowledgeable content because we strive hard to update and educate our viewers. Here's a video on how leading AI experts feel about AI. Do they believe a crisis is coming soon? Click on the video now to find out. See ya!